In this first problem, this is a review from yesterday. The first thing I do is I want to identify what type of a function is it. Somebody tell me, what type of function is it? Square root, correct? Square root, okay. Now, I want you to take back out this paper. We are going to start to come to this paper as we move through today's class period. When I create this simple table to start with, 0, 0. So I'm thinking of the most basic square root. Now, I do want you to see the correlation here. When I input in 1, the square root of 1 is 1. Watch. When I input 1, the square root of 1 is 1. What is the square root of 4? 2. I'm not going to go to 9, but the square root of 9 would be 3. Do you see how these columns work together? The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. We are learning that now because we're going to use this for cube roots, which you have not learned later today. So, the next thing I'm going to do after I identify what type of function it is, by the way, if you haven't learned this, come up here and make a really small 2. This is referred to as the nth root. Make sure you're not talking when I'm talking. If you don't see a small number here, it's a hidden 2. If you may be wondering why, let's take a step and let's look back right now at an expression. If you were going to teach this to somebody who had never seen this, you would say, what two exact numbers multiply to give you 25? And the answer is 5 times 5, correct? 5 times 5. All right, so that's this idea with an nth root. That's the idea with an nth root. Later on, we're going to see when this number changes to a 3, a 4, and so on. Okay, the second step after I identify what type of function is, and I have my basic table, is going to be I want to find that point. I know the general shape, by the way, is like this. That's the general shape. Okay? If I have not translated it, I haven't reflected it across the y-axis, across the x-axis, this is the general shape. Now, let's go back up here, bless you, and let's rewrite this. -2 plus 3. If there's a negative in front of the x inside of the radical, we're going to pull it out. So this is x minus 4. If I distributed the negative sign, I'd still end up with -x plus 4. Now I can properly identify the horizontal and the vertical shifts. I'm going to shift this to the right 4 and down 2. Right 4 and down 2. This is, please be quiet, this is where my point is. Now, I tell students who are feeling a little bit confused afterwards to go up and just cross those out. We've used those 2 points. This is going to allow us to see this shape. How fast does it rise? So we are right now, we are going to stretch this by a factor of 3. It's going to rise by a factor of 3. So I'm going to take an arrow here, and I'm going to draw an arrow from the 3 to the y. Now, the other thing we have to be aware of is that negative sign inside. Please draw an arrow from that negative sign to your x column. So if I rewrite this, 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6. Oh, on the other side, when I multiply by is negative, I get 0, -1, and -4. How do these help us? Because these now help create the shape, the proper shape. 0, 0 is always where our translated point is. From there, -1 says go left 1, positive 3 says go up 3. So I'm going left 1 and up 3. 1, 2, 3. I'm going to go back to the original point. I'm going to go left 4, and I'm going to go up 6. Left 4, 1, 2, 3, 4, and up 6. 1, 2, 3, 4, 5, and 6. And it's now looking like this. First thing I would do for this particular problem is I'm going to identify what's the parent function. This is the parent function. And I know for this parent function, when I input 0, I get 0. Input 1, I get 1. Input 4, I get 2. Now, could I also input values like 2, 3? Sure, but I'd get irrational outputs, and I want to graph nice integer values. Okay, the next thing I'm going to do is I'm going to rewrite this. Because I see a negative inside, I'm going to pull out that negative. I'm going to have x plus 5. Let's make sure that looks right. If I distribute that negative sign to the x and to the 5, I would still end up with negative x minus 5. Negative x minus 5. Okay, so our next step here was going to be to identify that initial point. So I have a horizontal shift to the left 5 and up 1. This is my point, and I often tell kids to cross those out. This value here is going to impact. We are not only going to stretch this by a factor of 2. It's also going to be reflected across the x-axis, and that's before the shift happens. And we're going to reflect this across the y-axis before that shift happens. So what we do right now is we're going to multiply this by negative 2. 0, negative 2, negative 4. Over here, multiplying by is negative 0, negative 1, negative 4. There's my 0, 0. I'm going to go left 1 and down 2. Left 4, 1, 2, 3, 4, and down 4. 1, 2, 3, 4. So here's a review of absolute value. So the very first thing we do is we identify the parent function. And then we think about if I have an input value of negative 2 and output values would be 2, negative 1, 1, 0, 1, 1, 1, and 2, 2. So I have the basic table that matches this parent function. Okay, now I'm going to look for where's that initial point of our V, whether it's opening up or the V is opening down. So this says I'm going to shift to the right 1, and I'm going to go up 2. This is the V shape. Now, again, I tell kids after you use that, cross it out so it's not so confusing. This outside value is always going to be multiplied, so what's directly in front, by the Y. So what that number is going to do is it's going to tell us whether the V opens up or the V opens down. Do you think it's opening up or down? Down. The larger the number, the skinnier the V shape. Okay, so it's going to mean stretch. Stretch means it's skinnier. Skinnier than the parent function. Multiply each one of these by negative 3, and I have negative 6, negative 3, this should have been a 0, sorry, 0, negative 3, and negative 6. So from this point, this is my 0, 0, I'm going to go 1 to the right and 3 down, 1 to the right and 3 down, 1, 2, 3. From this point, I'm going to go 2 to the right and 6 down, 2 to the right, and now 6 down, 1, 2, 3, 4, 5, 6. I'm going to do the same thing the opposite way. 1 to the left and 3 down. 2 to the left and 6 down. And this creates this absolute value shape that's been translated, right? Remember, there's no calculators allowed during this activity. Let's start right now with a negative 2. If I take negative 2 and I multiply it by itself 3 times, well, remember, 3 negatives make a negative. An odd number of negatives multiplied together creates a negative. And 2 times 2 times 2 is negative 8. Please don't talk to me when I'm doing this. Please don't talk to me when I'm doing this. If I change this to a negative 1, being sloppy here, again, 3 negatives make a negative. And 1 times 1 times 1 is 1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Please create your shape, whether you're using the paper from yesterday or you're creating a new, very simple Cartesian plane. Let's graph this parent function. Here is 0, 0. I'm going to go up 1 and over 1. I'm going to go to the, so I've done this. I'm going to go to the right 2 and up 8. So right 2 and up 8. I'm going to go left 1, down 1, and left 2 and down 8. And this is the general shape we have. This is the function we're going to do together next. Please write it down. Y equals 2 times the quantity x minus 3 cubed, subtract 4. The very first thing you do is you identify what is the basic parent function. Here is the basic parent function, and I'm going to make a table for that. So negative 2, negative 1, 0, 1, and 2. 8, 1, 0, 1, 8. Now I'm going to identify what is this point when I translate it. where does the origin of this problem go when I translate it? So, just like we see with other problems, I'm going to move it here, not to the left 3, but to the right 3, and I'm going to shift it down 4. Did I forget to put my negatives in here? Thank you. Okay, so I shifted it to the right 3 and down 4. Okay, so this, please, guys, put a little star here. And that's just so as we start here, we know this is this initial point that used to be at the origin. Now, to this, we are going to stretch this by a factor of 2. Again, I tell students that are a little bit confused, cross out those numbers that we just used that represented the vertical and the horizontal shifts. Take this 2 and please draw an arrow to the y's. This becomes negative 16, negative 2, 0, 2, and 16. Now, there's no way I'm graphing something all the way out to 16 on this, but we get the general idea of this, the general idea. So from here, which is like 0, 0, I'm going to go 1 to the right, but instead of going 1 up, I'm going to go 2 up, because I'm stretching it vertically by a factor of 2. Please don't talk when I'm talking. So there's up. So I've done this one, and now I'm going to go left 1 and down 2. Left 1 and down 2. Okay, I've done those 2. Now I'm going to go to the left 2 and down 16. I'm just going to approximate this. Left 2 and down 16 is probably somewhere way down here. And I'm going to go right 2 from this point, 1, 2. And I'm going to go up 16. Well, let's see. Here is 4. We're going to go way probably about there. Something like this. All right. So it's going to come up like this and down like this. I want you to make a prediction. Please write down this problem, but do not. The very first thing I do is I identify this, don't talk when I'm talking, as being an x to the third. That's the very basic x cubed, very basic parent function. I'm going to make my list. If you see I made a mistake last time, thank you for catching that. So I have negative 2, negative 1, 0, 1, 2. Please no talking. Negative 8, negative 1, 0, 1, and 8 again. I'm going to take this and move this to the left 2. I'm going to take this and move this up 4. That is that center point of x cubed. Now, I'm going to take each one of these, I'm going to bring it down here, and I'm going to multiply it. So half of 8 is 4, and notice a negative times a negative is a positive. Half of 1 is 1/2, again positive. 0 is not impacted. Half of 1 is 1/2, and there's a negative, and the same thing for 4. So from this point, I'm going to go 2, let's do this one, 1 to the right and down 1/2. 1 to the right and down 1/2. From this point, I'm going to go 2 to the right and down 4. Back to this point, 1 to the left and up 1/2. And lastly, 2 to the left, 1, 2, and up 4. So it's looking something like this. Okay, so what we're going to do is we're going to make ourselves a table. Now, if this was a 2, a 4, a 6, an even number, I'm limited to what I can plug in. If you think back to last chapter, and we thought of the 3 different scenarios, which we called risky situations. Now, if you remember, when this is an odd number, I'm allowed to plug in all real numbers. There's no limitation what I can plug in when this is an odd number. So, I could plug in all numbers, but just like we did with square roots, we want to plug in numbers that result in nice integer outcomes. So let's look over here. If I take the cube root of 1, guess what the answer is? If I take the cube root of 8, guess what the answer is? Okay, so I'm going to go in the middle up here, in the middle. I'm going to do 0. If I plug in 0, the answer is 0. If I plug in 1, the cube root of 1 results in 1. You're making this table on your paper with me. If I plug in 3, the result is 2. Now, if you're lost, this is what it means. What times itself 3 times equals 0? And the answer is 0. This function means what times itself 3 times equals 1, and the answer is 1. What times itself 3 times equals 8? The answer is 2, because 2 times 2 times 2 is 8. Now the exact same thing, making it very easy, we can put in negatives here. We get -2 and -1. Let's graph this together. It's like taking this basic function we had before that I threw into the garbage can. It's like taking this basic function. Look at the similarity, guys. Does everybody see this? And you are going to see how this relates to our next function. If I was able to flip this and turn it again, flip it around again, okay? It's this basic function that we're going to turn on its side and reflect. So here we go. I have 0, 0, done. I'm going to go over 1, up 1. I'm going to go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go up 2. -1, -1. 2, 3, 4, 5, 6, 7, 8. Down 2. And it makes this basic function. So we learned about inverses earlier, but can you see how these look similar? You see how these have this basic similar shape? Later we'll graph them on the same graph. We'll graph the line y equals x, and we'll see exactly how they reflect across the line y equals x. All right, let's get in one more problem here as practice. Please write down y equals. Let's go with 2 cube root of x minus 1 plus 3. We are going to do this together. You can't see it, can you? How about it just switched off? So read it off to me, please. 740. What is it then? 051? Okay. All right, so the first thing I do is identify what is the most basic function, and this is a cube root function. Please don't talk when I'm talking. And then I'm putting in what is the most basic. Okay, and I have -2, -1, 0, 1, and 2. All right, so the next thing we're going to do is we're going to identify that horizontal shift. I'm going to go to the right one, and I'm going to go up 3. Right 1 and up 3. And then I suggest, as we learn, this crosses off so there's less confusion. This already provided for me what points I'm going to use. So if you want to cross it off, go for it. The number out front that's stuck in front gets multiplied by the y's. Why? Because we're stretching this by a factor of 2. That leaves me with -4, -2, 0, 2, and 4. This is my 0. I'm going to go right 1, up 2. Right 1, up 2. I'm going to go right 8. So I'm at 1, 2, 3, 4, 5, 6, 7, 8. And I have to go up 4 from here. So from here I have to go up 4. Okay. 1, 2, 3, 4. And now I have to go the other way. I'm going to go from here, left 1, down 2. And then left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 4. And this is my shape.